We've all been there, right? You're coding along, everything's going great, and then, bam, your program just crashes. It's that sinking feeling. But what if I told you that you could actually anticipate those crashes and tell your program exactly how to handle them with grace? Well, that's what we're going to do today. Let's dive in and turn you from a victim of errors into a master of your code with Python exception handling.
So let's start with a question we all know the answer to, unfortunately. You've written your script, you hit run, and nothing. Everything just grinds to a halt. You're just staring at a wall of angry red text, and your program is completely dead in the water. It's so frustrating, right? But what's really happening under the hood? Well, your program has just hit a problem it has no idea how to solve.
Take a look at this super simple line of code. We're asking Python to do something that's, well, literally impossible. Divide 10 by 0. Even before you run it, you can feel that this is going to cause some trouble. This is the perfect classic example of code that is absolutely destined to fail.
And boom, there it is, the zero division error. That one line of text is enough to bring your entire program to a screeching halt. This is exactly what happens when an error goes unhandled. But don't worry, we're about to learn how to catch it.
You see, this crash isn't just a random event. It has a formal name in Python. It's called an exception. I like to think of it as your program throwing its hands up in the air and just yelling, "I can't do this! I don't know what to do!" And understanding what an exception really is, that's the first step to taming it.
So here's the core idea. An exception is just an error that pops up while your program is running. Now the key phrase here, the most important part, is if not handled. Because an unhandled exception means your program crashes. But a handled exception, that's a program that keeps on running smoothly, just like you wanted it to.
Okay, so how do we actually build this safety net? How do we handle these things? Well, let me introduce you to your new best friend, the try and except block. This is your first and, honestly, your most powerful tool against unexpected crashes.
This comparison says it all. On the left, you've got the code that just blows up. On the right, look what we did. We wrapped that same exact risky line of code in what's called a try block. Now, when Python hits that zero division error, instead of crashing, it just jumps down to the except block and runs that code instead. No crash, just a clean, controlled response.
And the logic behind this is beautifully simple. Think of it like you're driving down a road. The try block is your main highway. You're just cruising along. The accept block? That's a planned detour. If you hit an unexpected roadblock, an error, you just calmly take the detour. But if there's no roadblock, you never even see the detour. You just keep on going. Simple as that.
But we can get way more sophisticated than just a single detour. I mean, what if there are different kinds of roadblocks? A flat tire is different from a bridge being out, right? Python gives us the tools to handle different errors in different ways, and even to do things only when everything goes right, or to do cleanup no matter what happens.
So check this out. Inside this try block, we've basically set up two potential landmines. First, it tries to turn the letters A, B, C into a number. That's never going to work. It immediately triggers a value error. The code jumps straight to the accept value error block, and that's it. It doesn't even get to the next line to try dividing by 0. The first error that happens is the only one that gets caught.
Now, you can also just throw out a giant catch-all net. The general exception will catch almost any error that comes its way. This is pretty handy for logging errors you didn't expect, like we're doing here with that little variable e. But, and this is a big but, you have to use this with caution. If you use it too much, it can actually hide bugs and make your code fail silently when it should be telling you something's wrong.
Okay, this table right here. This is your ultimate cheat sheet for the whole structure. You already know try for the risky stuff and except for when it goes wrong. But look at the additions. There's an else block, which is like a little victory lap. It only runs if the try block succeeded perfectly. And then there's finally. Think of finally as the cleanup crew. It runs always, whether there was an error or not. It's absolutely essential for things like closing files or database connections. So far, we've pretty much been playing defense, just reacting to the errors that Python throws at us. But true mastery comes when you start playing offense. You get to define what counts as an error in your own application, which makes your code way safer and clearer about what it needs.
Take a look at this check age function. Syntactically, the code's fine, but our application has a business rule. You have to be 18 or older. So, by using the raise keyword, we can enforce that rule ourselves. We are intentionally creating an error if the age is too low. We're not just reacting anymore, we're proactively making our code more robust.
And it gets even cooler than that.
You can invent your own error types from scratch. By creating a new class that inherits from exception, like our custom error here, you can make your error handling incredibly specific to your program. Imagine you're building a banking app. You could create an invalid transaction error or a user not found error. It makes your code so much easier to read and debug.
Okay, so we've covered all the tools in the toolkit. We've got try, except, else, finally, and raise. Now let's put it all together. How do the pros use these tools to write code that's practically crash-proof? Well, it all comes down to a few key best practices.
So here it is, your checklist for writing professional, robust code. First, always try to catch specific errors, not just the giant exception net. Second, use finally for any cleanup that absolutely must happen. Third, and this is a big one, avoid bare except clauses. They can swallow up real bugs and leave you scratching your head. Fourth, log your exceptions so you can debug them later. And finally, don't be afraid to raise your own exceptions to enforce your code's rules.
And that pretty much brings us to the end. You now have the entire toolkit to take complete control over your code when things go wrong. So the question I have for you is this. As you go back to your own projects, what unexpected errors are you going to prepare for now? Maybe a file that doesn't exist, bad input from a user, or some invalid data? Go turn those potential crashes into controlled, predictable outcomes.